So in the uh, previous session, so we had written a code that actually simulates the stock market, and it also enables us to design and randomly generate the stock prices based on some standard equation, and we could use a single one LSTM network, right? That was designed with the name layers, and we could train and perform the test, and we could also perform what was called as the estimation, right? So we could plot and check, right, what the machine has learned, is it correct or not. All right, let's quickly run this section once. Right, this is the first part, right, which generates the stock price. Then in the second part, we generate the training and the testing samples. Then this designs the neural network, deep neural network with the LSTM as its fundamental layer. Okay, so once that is over, after the analysis part of the neural network, so if you remember, we tried to go with the training options and the training, right? So that actually starts the training of the neural network, and we can see that the training and its corresponding uh, table will come, and once we have that, once it finishes, then we will go for the testing part. Okay, so that actually begins the training on our GPU, and as you can see, right, since we opted for what is called as the verbose, right, we can see that, right, we can see the epochs, right, being displayed on the screen. Okay, so let it finish. As soon as that happens, we will go ahead and do the prediction part, and also we'll plot a figure. So as you can see, 500 iterations or 500 epochs are over, right? And right, all the values we can see that it is a it's the same value, right, for the last few epochs over here, right? Which means there is a convergence. right? That has been achieved. Now we'll proceed further. We'll go to the predicted part, and once the predicted is done, now we'll go for the plotting. So now I'll bring up the plot, right? So you can see that, right? The first part up to 8 is blue color, which is the training data. Then we have a green color data, which is actual data, and the prediction is almost matching for the initial up to say 8.5, 8.75 or something. But after that, there is a deviation. Okay, so there is a steep increase in the actual price of the stock, but what machine could predict after 9, you can see that there is an error. Okay, so this is what we have done so far. So now our objective is that we want to give an option. We want to write multiple codes over here. What if the user wants to use different types of neural networks, right, in the code? We want to give a choice to the user so that the user can opt for the usage of any specific type of the network, right? So I'll try to write one or two types of what you call layers. Okay, but if at all, right, you want to increase, definitely you can go beyond that, right? You can add different types of networks as well. Okay, right. So what I do, I'll try to uh, copy this. Let's try to copy this because the most of the code is going to remain same, right? And let me create a new, what you call, new file. Okay, so that is my my stock market. I'll write multiple LSTM, various types of LSTM I want to incorporate over here. Okay, so I just open that and let me just paste it over here. So let's try to follow what we did from the beginning. I'll just tell you where I'm going to make a modification. Right, so first part still remains same. I'll try to run this part so everything is clear. So here you see you are simply trying to define the various types. Okay, so this is the data, right? The data is getting created over here, so I don't want to make any change in this. Okay, so let's proceed. So that creates your this thing, the data, and you are trying to convert the actual data into the normalized data and call it as training data, testing data, and the validation data. Correct. So again, here also I don't want to make any change. This is obvious. Let's proceed. Right, now the change comes into picture. The change is, right, in terms of what type of the neural network, right, I'm going to use, right? Because I want to give multiple options here. So what I want, I'll do here is I'll give an option here. So just before entering into the definition of the various layers, I want to give an option. So I'll just erase this part. This is what I don't want. Right. So just before that, let me try to recall that I want to generate a specific, say, layer. I want to define that. All right. So, okay. use layer. In the sense, this is a variable which tells you what type of LSTM network you want to use. Let me say, okay, let me type something here. So let me say this is simple, maybe LSTM. This can be the, this is one of the options, right? I'll tell you what are the options available. Let me try to write. So the options available are something like choose from, right? One is LSTM. It's the one which we have used. Okay, either I want to use this, otherwise you have another option, say this is by LSTM. Okay, that's the second type of LSTM possible. Or let me say, I'll show you, I want to show you this as well. What if I want to concatenate two different LSTM layers one after the other, right? So there is a difference. So I'll write say two LSTMs. Okay, let me call like this, right? So you can choose, you can write either LSTM as shown here, otherwise you can replace it as a by LSTM here, whatever you can choose, or even we can write 1 2 3, but what is 1 2 3 I need to tell. So that's why I'm trying to specify exactly what I want to use, okay, by the name. So now you see what I do, I go for the switch case, right? Inside the switch, I'll tell you which layer has been chosen, what should be the layer. That's what is the modification we are going to do. Okay, so the name the use, this use layer which we have used here, right? That's what we are going to switch now, right? In the sense, if it is LSTM, do something. If it is by LSTM, do something else. If it is two LSTMs, do something other than that. Okay, right? So again, this is going to help you in understanding the uh, concepts of a switch case. All right. So okay, so this is the first one. So case, what's the case? Say I choose LSTM as the network. So in that case, what you are going to use, you define the layers. So it means it is a single LSTM. I'm supposed to use only one LSTM layer, right? So layers is equal to, right? Anyway, I know that my inputs are coming as a sequence. So sequence input, sequence input layer, right? Already we defined what is the input size. So just use it over here. That's the size I want. Comma, you have to tell what name. What's the name of this, right? It is input layer, right? You can give any name you want, as you already know, right? So that's what, yeah, close this, right? Then I want to use a LSTM. So LSTM layer, right? LSTM layer will have some number of what you call hidden neurons, correct? So that is defined by number of hidden units. So I'll just paste that. So then you give a name to this, right? The name will be LSTM. Okay, that is done. Go to the next line and define what you want to connect next. If you recall the previous code, right? After the LSTM, I just want only one layer, right? One LSTM layer having 200 hidden units, correct? So immediately after that, what you connect? You connect all the 200 hidden units into generating into a next layer, which is a fully connected layer, right? So fully connected. layer, right? So fully connected layer should have output size. Output size is already defined, so just paste that over here. That's the output size. Okay, and generate a name that is equal to what's the name? Let's give a fully connected. Okay, that's a fully connected layer. So later on we are going to connect, since this is a regression operation, right? I need a regression uh, layer. So here you don't have to give any specifications like how many inputs, how many outputs, etc. Simply give a name. So the name should be uh, regression layer. Okay, so that defines the layers now. All right, so this is the case for which one? This is a case for the LSTM. Okay, now I'll go to another case. Now the second case, you can see that the second option I am giving here is a by LSTM. So now I need to specify what are the layers I am supposed to use if I am using the by LSTM. Okay, so layers equal to, so I have to use a semicolon over here. Okay, right? Okay, so layers is equal to, once again, input will remain same. So sequence input, it's a sequence input layer, pretty much same as the previous cases. So I'll give a, that's input size, comma, enter name as input layer. Go to a new line. Now you see the difference comes uh, into picture. So instead of a LSTM, now I should use a by LSTM. So if you remember, the keyword which specifies I'm going to use a by LSTM layer is, right, the by LSTM layer. Okay, it's a by LSTM layer, and I should pass the same number of hidden units, right? Specify the name as by LSTM layer. So after that, after this by LSTM layer, right, then I'm going to pass it to the fully connected layer. So the layer is changed to by LSTM, right? Then the output of this by LSTM layer needs to be passed on to a fully connected layer. Okay. So that is fully connected, fully connected layer. Again, you will specify whatever is the output size, right? The same output size should be given here. So give a name that is equal to the fully connected layer. And finally, we need another regression layer. So I'll just pass this as it is. Okay. Now we can see that, right? So the in case of the by LSTM, this is how the layers will be designed. Okay, so then we have two LSTMs. That's a new case. Okay, let me enter this as it is. If this is the case, right, I'm going to define layers that should be equal to, right? Now you see, I'm going to have input layer will not change. All right, so let me enter the input layer as it is. So that's the first one. Just copy and paste. Okay, sequence input layer, right, of this much size. This is what I want. Then you see, I'm going to use a LSTM layer. Okay, so let me go for a LSTM layer as it is. Okay, so LSTM layer is done. Now you see, I'm not generating a fully connected layer because I want to use two LSTMs. Okay, so the idea is that you recall what we did for convolutional neural networks. Whenever I had multiple hidden layers, what was the idea? Do you remember what was our idea? What was the activation function? Because I need an activation function now, right? Between multiple hidden layers, you have to use a activation function. So just try to recall, right? What was the activation function used, or what's the name of the activation layer? Yeah, obviously that's correct. So right, we need to use what is called as a, it's ReLU, right? The keyword is ReLU layer in MATLAB. Okay, so ReLU layer. So specify, I don't have to tell anything, right, about the inputs or something. I just have to tell what name I want to show. Okay, name is ReLU layer. All right, so I define that I need a ReLU layer here. Now, once again, the LSTM will come into picture. Okay, so what I make change. This is LSTM layer 1, this is LSTM layer 2, right? Because I'm using multiple layers. Now you see, after this LSTM, right, I want to give the output to the actual output layer, right? So before the output, what you need to use, a fully connected, right? That's what is the default. So I use fully connected, and after fully connected, since my objective here is to perform a regression than a classification, so you will use which layer? The regression layer. Okay, fine. So only the change is that we added a LSTM layer. So definitely you can go ahead and do one more layer. So copy this and paste below this once again. That add a ReLU here, followed by another LSTM, right? So you can actually, right, make the changes as required. So now this is what my objective here. I wanted to show you two things. One is that, okay, how do I use the switch case, right? How do I choose various types of networks, right? I have to define that, right? Definitely a switch case will help. Fine. The second thing is that by doing this, we will be able to uh, analyze the behavior of the various types of neural network. Maybe we may see, I don't know what's the result, what we will get at the end, right? If I use a simple LSTM, I can see one type of graph. By LSTM may improve the performance, maybe, as because just now we ran the LSTM case, and after certain duration there was some error, right? Machine could not predict, right, accurately. So if you want to increase, right, definitely one option is that we can increase the, I'll just go back to the old code. So maybe you have options to change the epochs, right, various parameters like this can be varied, and so that you can, right, improve the performance. That's one thing. The second option I wanted to show you is that you can change LSTM to by LSTM, right? And you can check whether will there be any improvement in the performance. And after that, we'll definitely run the next case, that is two LSTMs, right? So LSTM layers are cascaded over here, two different layers, hidden layers. Okay, so that's what we are going to see, and followed by that, right, maybe if that also is not sufficient, you can add another case below this. That's all. Okay, anyway, I don't want to go with the three LSTMs as of now, because I don't know what's the result for this. So in the switch case, we have another option coming up. Anything other than this is entered, you can simply throw up an error. Okay, so that is the keyword is otherwise. Okay, so inside this otherwise, you can say that you throw up an error. Error itself is a keyword. You just have to uh, tell what the message has, that has to be displayed. Okay, so I will end, I'll type three only three layers are available to choose from. All right, so anything else somebody entered means you will show this as an error. So you can choose something like this. Okay, so that's the error message I want to show, and immediately after that I want to come out, and I just want to end the switch case. So you can see switch begins here, it closes over. So immediately after that, I'll go for the analyze network. So whichever is the network that you have chosen, it will display. So this is the fundamental modification which we are doing. So now we can see that I have chosen LSTM, right? So I'm expecting the LSTM, I'm expecting my machine to create the LSTM layer and show, right, its result. Okay, let me, I think we ran till here, right? So this is run. Okay, we'll run this section. Okay, now, so what I'm expecting is, okay, since I called the analyze network function, I'm expecting the same. So you can see that there is a network analyzer that has been created, right? This actually has an input layer, LSTM layer, fully connected layer, and a regression. So this is the simplest layer. Okay. Now, so we'll run this part, and we'll see is there any improvement or any change that's happening. Okay, so now we have chosen this, so let's move ahead. So this part of the code will run. Okay, there will be training now. So I'll show you the training progress window, so that you can keep track of the number of epochs, right, that's happening in the form of a graph. And also we can trace out what is the RMS error, root mean square error, and what's the loss function. Okay, and below the table you can also see that, right, the values are going towards the convergence, and all the loss values are being reduced. Okay, so as we can see, right, the has uh, convergence has reached, right? It's all the values are coming closer to the same value for the last few iterations, correct? Right. So now we'll go ahead and we'll do the prediction. We'll run the prediction part, and also we'll run the plotting part. So you can see that the plot is like this, right? Again, the some part of the code is pretty much matching with the right actual values. The red and the blue, sorry, red and the green graphs are overlapping, right? But after that, when there is a too much of variation in terms of the stock values, right, the prediction is not exactly matching, right? Very much familiar, very much similar to our previous case, correct? Right. So that's the first part. That is a that's going to happen when I choose the simple LSTM. So we'll move to the second type. Only the change that you have to use do here is change your use layer, right? Use which layer? Use by LSTM. I'll just change it to this. So previous part of the code you don't have to run actually, right? Directly you can run from this section, right? Let me run that part. So now I'm expecting a neural network, right? That network should have a different, what do you call, LSTM layer, right? You can see that it's a bi LSTM layer now. It's not a normal LSTM. You can see the difference. Previously, we had the values like 800, 800, 800, like that, right? So now you see it's a bi LSTM. So you can see, right? What you can see here, it's right uh, by LSTM, right? One from left to right, one is from right to right, left. That two dimension, two direction, bi-directional. So it's a by LSTM. So everything doubles. So previously we had 200 activations. Now we have 400 activations. All right. So that's the difference. What we can observe. Right? That's what has been created. So we'll move ahead, right? So then we'll move on to the training part once again. Okay, so let's see, will there be any change in the performance? Let me bring up the training progress screen so that we can track it. Okay, so as you can see, the training process is completed. And from this particular table, you can see that now the error is actually slightly lesser than the previous case where we had 0.06, zero point zero 0.06 and something, right? So now we have slight variation in this value. So we can expect slightly different results. All right. Okay, so let's run this prediction part, and also I'll go ahead with the plotting part. Okay, so my data is not different now. You see, I have never, I didn't run the previous part of the code, in the sense this part, the training, testing data, etc. We have not changed. So what I'm expecting is my graph still remains same. Okay, so I'll just bring up the graph now. You can see, right? It's a very much same graph, right? So the data set is same, right? So performance, you can say that the red colored graph is coming closer to the green slightly, not very much. Okay, so the plots are pretty much closer. That's what I can say, right? So whatever variation is there, it's able to predict slightly better compared to, right, compared to the previous case, right? That's what we can see. All right, now let's go ahead and test the other case. All right, so the other case should be, I should enter the two LSTMs. Okay, instead of this, change it to two LSTMs, right? So that the machine should be able to create the layers according to the two LSTMs, and it should show, right? Again, you see, I'm not changing my previous part of the code. So testing and the training data still remains same. Okay, so before that, I just clear the screen so that we can visualize it clearly. So let me run only this section and go ahead, right? So now I'm expecting a different network. Okay, so different type of network. So I'll just show you what it created. Now you see the number of layers are different, right? You see the number of layers are 6 because we added new layer like LSTM1 and radio. Okay, so that's a new thing. Previous to that, we didn't have layer 2, layer 3, directly layer 1, 4, 5, 6. So totally 4 layers. So now we added 2 more layers. Now you see the difference, right? Instead of having layers, these are the names given. So you can see that the weights and there are separate amount of weights for this as well as this. So remaining part remains same. Okay, other parts are same. Okay, so that's how the network has been created. So now I expect slightly more time required for the training because there are two layers. Okay, fine. So let's go ahead and start training. Okay. So we can see that training progress here, and I just want to bring up the training progress screen as well, all right, for our reference. So that's how the training is. as we can see, the training is over, and we can see that there is convergence. Okay, so last a few of the iterations and the epochs after 450 or something, no, just before that. Okay, so around, see, the error is constant over here. So after 455, right? So that's the final error, right? It is of the order 10 to the power minus 7. So that's pretty close. Okay, so we finished the training, and now we'll go for the prediction part. So once that is done, let us try to plot. Okay, so right, since this is pretty much similar to my first case, so I don't expect any a huge amount of improvement in the results. Okay, so maybe I'm going to get some plot which is very similar to the old graph. Yeah, right. So you can see here, right? So there is a lot of error, right? Like the first case, what we had seen. Okay, so that is the difference. Right. Okay, so that's how that's the conclusion. So increasing the number of layers, right? Uh, actually didn't help, right? Maybe it has its own reasons for that. Uh, Possibly, right? The possible reason could be whatever the first layer has learned, the same thing is learned by the second layer as well. That's why, right? Again, we have option, like we can still make the changes in this part, right? And also we can add few more layers, right, below this. That's also might help, right? We have to do a trial and error. There is no fixed method saying that, okay, do this, the layer should be like this only so that you get a best result. It's not possible. Okay, so that's the thing here. Let's try to check out if we get any an error. Okay, so I'll just enter, say, ABC, right? I'm expecting an error to be thrown here. Okay, because as we know, right, if you enters anything else, it should come under the otherwise and throw up an error. So I just want to check that as well. Okay, so I'll just run this section, and you can see that it's an error, right? Only 3 layers are available to choose from, right? So that's how it is showing up an error, right? So again, this is just a I just wanted to show you how we can use a switch case to choose, give an option to choose from various types of layers, right? Also, I wanted to show you the various types of LSTMs that we can design. One is simple LSTM, bi LSTM, and 2 or more layers of LSTM, which you can add, right? So these are the multiple options available, right, under this particular design process.